We will start this homework session by solving problem 1. In this problem we are asked to determine if the integral from 0 to infinity of the function 1 over the product square root of x times 1 plus x is convergent or divergent. Moreover, if it converges, we are asked to find its sum. We will first investigate the convergence or divergence of this integral. We notice that the denominator will be 0 if x equals 0. So the function is not defined as x equals 0. This means the improper integral is a type 1 and type 2 improper integral. This integral is a type 1 improper integral because one of the endpoints is infinity. It is a type 2 integral because the function 1 over the product square root of x times 1 plus x is discontinuous at 0, and 0 is one of the endpoints. So, this integral should be broken into two integrals. The integral from 0 to 1 of 1 over the product square root of x times 1 plus x. Plus the integral from 1 to infinity of 1 over the product square root of x times 1 plus x. We have to study the convergence or divergence of both integrals. Let us first study the convergence of the integral from 1 to infinity of 1 over the product square root of x times 1 plus x. It is obvious that 1 is less than 1 plus x, for all x in the interval from 0 to 1. So, if we multiply both sides of the previous inequality by the square root of x, the inequality will be preserved, and we will have the new inequality, square root of x less than square root of x times the quantity 1 plus x. Therefore, 1 over the square root of x times 1 plus x, is less than 1 over the square root of x. So, the integral from 0 to 1 of 1 over the square root of x times 1 plus x dx is less than the integral from 0 to 1 of 1 over the square root of x dx. Which equals 2 times the square root of x evaluated at the endpoints 0 and 1. This is because the antiderivative of 1 over the square root of x is 2 times the square root of x. We therefore see that the integral from 0 to 1 of 1 over the square root of x dx equals 2. Consequently, the integral from 0 to 1 of 1 over the square root of x times 1 plus x dx is less than 2, thus it is convergent. Now let us investigate if the integral from 1 to infinity of 1 over the square root of x times 1 plus x dx is convergent or not. It is obvious to see that x is less than 1 plus x. For all x greater than 1. Consequently, the square root of x times x is less than the square root of x times 1 plus x. We take the integral of both sides of the inequality, and see that the integral from 1 to infinity of 1 over the square root of x times 1 plus x dx is less than the integral from 1 to infinity of 1 over the square root of x times x dx. Which is less than the integral from 1 to infinity of 1 over x to the power 3/2 dx. This integral is convergent by the comparison test with the test function 1 over x to the power p, with p equals 3/2 which is strictly greater than 1. So this integral from 1 to infinity of 1 over square root of x times 1 plus x dx is convergent. In sum, the integral from 0 to infinity of 1 over square root of x times 1 plus x is convergent because it is the sum of two convergent integrals. Now given this integral is convergent, we have to compute its sum. Now let us compute the value of the integral from 0 to infinity of 1 over square root of x times 1 plus x dx. We define the function f of x as 1 over square root of x times 1 plus x. Our goal is first to find an antiderivative of f of x. In order to integrate this function, we need to find the proper method. Given the shape of this function, the only viable method that we can use is the u substitution method. We set u equal to square root of x, thus du is 1 over 2 times square root of x, moreover, dx is equal to 2 square root of x du. The integral from 0 to infinity of 1 over square root of x times 1 plus x dx can be written as 2 times the integral from 0 to infinity of 1 over 1 plus x times the fraction 1 over 2 times square root of x dx. In this new expression of the integral, we can clearly see u and du. We easily see that when x equals 0, u equals 0, and when x equals infinity, u equals infinity. So the integral from 0 to infinity of 1 over square root of x times 1 plus x dx equals 2 times the integral from 0 to infinity of 1 over 1 plus u square. We all know that the antiderivative of 1 over 1 plus u square is the arctangent of u plus a constant of integration c. So our integral is equal to 2 times the arcade tangent of u evaluated at 0 and infinity. Which is equal to 2 times the arcade tangent of infinity, minus the arctangent of 0. Recall that the arctangent of infinity is pi over 2, and the arctangent of 0 is 0. In sum, the value of the integral from 0 to infinity of 1 over square root of x times 1 plus x dx is equal to pi.